Hello class, we're still on the topic of function rules in this unit, and what we're going to focus on today is how we can tackle word problems for function rules. Now before we dive into some examples, there's some terms that we need to be familiar with, which we'll look into much more detail when we talk about linear functions in the next lesson or two. So these two terms are some things that you need to know. The first term, rate of change, is how a value or measurement changes in relation to another measurement. An example of a rate of change would be like speed, like miles per hour or meters per second, or your hourly wage, how much you earn in a time period, like $8 an hour or $50 an hour. An initial value is the starting amount of an expression. So those are the two terms that you would probably see most often in these types of word problems that we're going to be dealing with. So let's start off by looking at the first word problem. And what I've done for this first word problem, I broke it up into a couple of steps, which is going to hopefully help us out with understanding how to read and interpret things when we're analyzing and comprehending function problems that are embedded in real life applications. So let's read number one. Rod is paid an overtime rate of $25 per hour after his basic wage of $600 for the week. So let's break this up into a couple of steps. The first thing we're going to do is determine what is Rod's initial earning. Well, his initial earning is basically his basic wage, what he starts with for the week, which is $600. And then what is the rate of change? Well, his rate of change is going to be his overtime rate. So you probably picked up on the keyword rate right there in the word problem to indicate that there is a rate of change, which is $25 per hour. So a lot of times if you see per a unit of time, that's indicating a rate of change. So we would write that as, so our rate of change is $25 per hour. So now what we're going to do, we're going to write a function rule that represents Rod's pay as P of H, so we're using function notation. So Rod's pay is P of H if he works H hours of overtime. So what we need to do to write our function rule, we need to establish a couple of things. So in order to write the function rule correctly for a situation like this, we need to make sure that we start with the initial earning, and then we add the rate of change. And that's why we identified those couple of things earlier, because that's going to help us out for setting up our function rule. So P of H, our pay per hour, or our pay for the number of hours Rod works, will be his initial earning of $600 plus $25 per hour. Per hour indicates an operational multiplication, so we would write that as 25 times H, or 25H. So that's how we would write our function rule out for number one. So now let's take a look at the next situation down below. Here's our second example. An airplane 30,000 feet above the ground begins descending at a rate of 2,000 feet per minute. Assume the plane continues at the same rate of descent. Write an equation to represent the height of the airplane in feet above the ground, f of x, so we're going to use function notation again, in relationship to time in minutes, which is x, which is our input variable. So let's determine how we're going to write some things out. So f of x, remember, we're going to start off with our initial amount, which is the 30,000 feet. So 30,000 feet. And the plane descends. minutes at a rate of 2,000 feet per minute. So this is very important to note right here that we have a rate that is descending. So it's not positive. We're going to represent that as a negative rate of change. So to represent that, instead of writing plus, we would write minus 2,000 feet per minute, or x. So that's how we would write our function rule out for this situation. Let's take a look at number 3 now. I'll read it out loud. It says a plumber charges a fee of $50 to make a house call. He also charges $25 per hour of labor. So if you would like to, you can pause the video right here and you can try these two parts out on your own first. And then once you've worked out these two parts, hit play to compare your results to my work. So let's go ahead and tackle this. So part A says write a function rule that represents the total cost the plumber charges as y and the number of hours of labor as x. So those are our two variables that we're going to use for our function rule. So remember, y and f of x are used interchangeably a lot of times. So we're going to start off with the variable y since that's our output variable. So let's think about how we're going to structure this. So first we need to make sure we identify our measurements in this problem. So it looks like we have an initial charge of $50. So that's our initial amount. And then he charges $25 per hour. Oh, we see that word per again right there. So that's indicating a rate of change. And he's charging an extra amount, so plus $25 per hour, or we're treating x as our variable. So there is our answer for part A. So here's what we're going to do for part B. It says if the plumber works for 8 hours during a house call, how much does he end up charging for the house call? Well, 8 hours, well remember, x in this situation represents the number of hours of labor. So what we're going to do is we're going to plug in 8 for x and then solve the function for that number by plugging it in. So we end up with this statement. So 50 plus 25 times 8. Well, if we simplify this down, 25 times 8 is going to be 200. So that's 50 plus 200, which gives us a total amount of $250. So let's take a look at the last question, number 4 for our example in this lesson. It says Howard decided to start jogging every day at the track. He completes the following chart for the first month that he jogs every day. Use the table to write an equation to represent the number of laps as L and the time in weeks as T since Howard began jogging. So we're using two variables, T and L. We're going to treat T as our input variable for this problem, and we're going to treat L as our output variable. So remember, the output variable is always going to be the one that's dependent upon how we write our expression out. So what we need to do is figure out some things. So it looks like, according to the table here, let's see if we can analyze and determine some behavior in our function. Well, at the time t equals 0, this indicates his starting amount right here of how many laps he starts off running. So this number right here, when t is 0, gives us our initial amount. So that's the number we're going to be starting with in this function rule. Now, we need to figure out what the rate of change is. And the way we can do that is by comparing how the output value changes per unit of time. So if you look here, as we that for every week that passes, it looks like it increases by 1 lap per week. So if we wanted to write that as an expression, we would add 1 lap per unit of time. Now, 1 times t, that's a little redundant. You don't have to put that down. So if you wanted to simplify that, you can just write that as 4 plus t. Now, if you're ever uncertain about whether or not you write a function rule correctly from a table of values, one thing that you can do to double check to make sure that the expression is consistent with your data is by taking the input value and testing it out to see if it corresponds to the matching output value in your table. So if we plug 0 in, 4 plus 0 is 4, so we know that works. Plug in 1, 4 plus 1 is 5. If we plug in 2, 4 plus 2 is 6. And if we plug in 3, 4 plus 3 is 7. So we know that that is consistent and that it works out. So that's just a sample of some function word problems that hopefully was clear and easy to follow through. If you have any questions, by all means, feel free to email me. I'll be glad to help you guys out with any problems that you have for the practice problems I'm going to give you for your assignment today. Hope everybody's doing well, and take care.